In the last lecture, we considered distance time, velocity time and acceleration time graphs. In this lecture, we shall consider kinematic equations and see how problems based on these equations can be solved. Kinematics is the subject where the forces responsible are not taken into account. If the forces are taken into account, then the subject is called dynamics. Here we consider kinematics, and these kinematic equations are relations between initial velocity, final velocity, distance covered, time taken and the acceleration involved. The relation between the initial velocity u and the final velocity v and time t and acceleration a can be found in the following way. We know that a is equal to dv by dt. So, we integrate this and we get v equal to integral of a dt, or v is equal to a t plus a constant. The constant is determined by the initial conditions. We say at time t equal to 0, velocity is equal to the initial velocity u. Therefore, we get the equation v equal to u plus a t, because the constant becomes u. Now, for the next equation, we use the relation v equal to ds by dt. So, that s is equal to the integral of v dt. From the previous equation, we have already seen that v is equal to u plus a t. So, we substitute v equal to u plus a t in this integral, and then we integrate. What we get is s is equal to u t plus half a t square plus a constant. This constant is again determined by the initial condition. If initially s is equal to 0, then the constant is 0 and we get the equation s is equal to u t plus half a t square. On the other hand, if at time t equal to 0, s is equal to some value s 0, then the equation becomes s equal to s 0 plus u t plus half a t square, because s 0 is in this case the constant of integration. If we eliminate between these two equations, that is v equal to u plus a t and s is equal to u t plus half a t square, then we get the third equation, which is v square minus u square is equal to 2 a s. And I want to remind you that these relations are true only for uniform acceleration. This is the point which we generally forget. We can also derive these equations graphically. In fact, in the last lecture we did this. We can see that the distance covered here in the velocity time graph is equal to the area of this rectangle and the area of this triangle, and if we add them, we get v equal to u plus a t. We get this distance as a t, and therefore, the velocity is u plus a t, and the distance covered is the area under this curve, the area of the triangle plus the area of the rectangle, and we get s equal to u t plus half a t square. This we did in the last lecture also. Now, how do we solve problems? I mean, students have great difficulty sometimes in using these equations to solve problems based on them. We shall try to remove this or lessen this difficulty by taking many problems. First of all, when you are given a problem, write down the full set of quantities u, v, a, t and s, and then write down the quantities which are given. Suppose you are given u, v and a, and you are asked to find s. Then you look at the appropriate equation which joins or which connects u, v, a with s, and one of these equations is s equal to u t plus half a t square. So, we can use that equation to find s. We can use also v square minus u square equal to 2 a s to find s if we know the final velocity and the initial velocity. So, first make a full set of quantities available to us, then those which are given, and then find the equations which connect those quantities. Let us take this example. A biker is moving at a speed of 72 kilometers per hour. When he notices that the traffic light ahead of him has turned red, he applies brakes and brings the bike to rest in a distance of 20 meters. What time did it take to come to rest? Now, what are given? We are given the initial velocity u, which is 20 meters per second. We are given the final velocity 0 because he comes to rest, and we have to find the time t. So, we use equation v square minus u square equal to 2 a s. Because we know the final velocity, we go to the initial velocity, we know the distance covered, therefore, we can find a, and we find a in this case to be minus 10 meters per second square. This minus sign is important. You see, you remember that the biker has applied the brake, and therefore, his speed is decreasing. That means, the acceleration must be negative, and we must get the correct sign of the acceleration. In this case, we get a equal to minus 10 m divided by s square, that is meter per second square. Now, the other thing that we have to find is the time taken. For that, we can use the equation v equal to u plus a t, plug in the numbers. U is 20 meters per second, a is 10 meters per second square with a negative sign we have just found, and therefore, t we can find from this equation, and t turns out to be 2 seconds. If you want, you can verify this result by using the third equation, that is s equal to u t plus half a t square. Let us take the opposite case now. You are waiting at a crossing because the traffic signal is red. It is good to wait for the signal to become green. As it turns green, you move ahead and cover 20 meter in 2 seconds. What was your acceleration? What was your velocity at that instant? Again, we note that we have given initial velocity, which is 0 because we started from rest. We have given time t equal to 2 seconds, and we are given distance equal to 20 meters. For the final velocity, we have to find v, and we have also to find a. Now, equation connecting the given quantities, and a is s equal to u t plus half a t square. We use this equation, and we find a equal to 10 meters per second square. Once we have found a, we can find v. V is equal to u plus a t. Substitute the value of u and the value of a we have just found. T is 2 seconds, and we get v equal to 20 meters per second. Another example, your friend boasted that his car can attain a speed of 72 kilometers per hour in a distance of only 70 meter. Verify his claim if the car is rated by the manufacturer to go from 0 to a speed of 108 kilometers per hour in 15 seconds. Assume uniform acceleration in both these cases. Let me remind you that a car manufacturer gives you what speed the car can attain in a certain distance or a certain time. In this case, the manufacturer says the car can get a speed of 108 kilometers per hour in 15 seconds. Okay. So, let us verify the claim of your friend. We first look at what the car is capable of. It goes from a speed 0 to speed 108 kilometers per hour, that is 30 meters per second in 15 seconds. So, we use v equal to u plus a t and get a. A turns out to be 2 meter per second square. With this acceleration, in order to attain a speed of 72 kilometers per hour or 20 meters per second, the car will require to travel a minimum distance s given by v squared minus u square equal to 2 a s. So, we substitute the values and we get s equal to 100 meters. So, that is the minimum distance that car must travel to get to a speed of 72 kilometers per hour. So, therefore, the claim of your friend that car can attain a speed of 72 kilometers per hour in a distance of 70 meters is incorrect. He is boasting, he is telling lies. Take another example. A runway is being planned at an airport. If an aeroplane has to acquire a speed of 288 kilometers per second for takeoff in 32 seconds, what should be the minimum length of the runway? If you have seen an airport, there is a long road on which the aircraft travels, attains speed and then ultimately takes off. This road is called runway. So, let us see what the length of this runway would be if the speed acquired by an aircraft is 288 kilometers per second in 32 seconds. All right. So, let us solve this. We have to find the distance in which the aeroplane will accelerate from 0 speed to 288 kilometers per hour or 80 meters per second. That is, we are given initial speed, we are given the final speed, and from v equal to u plus a t, we find that a must be equal to 2.5 meter per second square. You substitute the values and get this, and then use v squared minus u squared to get the distance in which the given velocity has to be attained. You see, s is equal to a t square divided by 2 into 2.5 meters per second square, and we get the result as 1280 meters, that is 1 kilometers 280 meters. The actual length of runway is much larger than this, because there are other considerations. In fact, the famous T3 terminus of the new Delhi airport has runway of about 4 kilometers. Let us take the next example. Suppose an athlete could run 100 meters with a constant acceleration of 0.7 meters per second. What would be his speed at the end of the race? Solution: initial velocity u being 0, a and s being given, we use v squared minus u squared equal to 2 a s to get v equal to plus minus root of 140, which is equal to plus minus 11.8 meters per second. I have taken this example to illustrate the fact that when you take square root, you must consider both the signs, plus sign as well as the minus sign. So, in this case we have got the two signs. The velocity could be plus 11.8 meters per second or minus 11.8 meters per second. In such a situation, we must apply extra consideration to choose the correct sign. You see, negative sign in this case is obviously incorrect, because the speed is positive. Therefore, we can reject the negative sign, and therefore, we get the result that the speed acquired by the athlete is 11.8 meters per second. This appears very high, but remember that the world's fastest man, that is Usain Bolt, is reported to develop an even higher speed, that of 12.27 meters per second. Another example: an object moving with initial velocity u covers a distance of 20 meters in third second, not in 3 seconds. Please note, in third second, and 26 meters in the fourth second. Find the acceleration and the initial velocity of the object. Once again, let me remind you that the distance covered in third second is the distance covered in 3 seconds minus the distance covered in 2 seconds. Similarly, the distance covered in fourth second is the distance covered in 4 seconds minus the distance covered in 3 seconds. So, we write the appropriate equations. If a denotes the acceleration, then the distance covered in 2 seconds is 2 u plus half into 4 a, and the distance covered in 3 seconds is 3 u plus half into 9 a, and distance covered in fourth second is 4 u plus half into 16 a. Now, if I subtract S2 from S3, I get the distance covered in third second, that is u plus 5 by 2 a. If I subtract S3 from S4, I get u plus 7 by 2 a, distance covered in fourth second. In general, the distance covered in nth second is equal to u plus half a into 2 n minus 1. In this case, we have got 20 meters equal to u plus 5 by 2 a and 26 meters u plus 7 by 2 a. Solve these equations and we get a equal to 6 meters per second square and u equal to 5 meter per second. But this formula is important. The distance covered in nth second is u plus half a into 2 n minus 1. Another example: a biker is moving at a steady speed of 72 kilometers per hour on a stretch of a road where the speed limit is 60 kilometers per hour. I hope you remember that on all roads there is always a speed limit, and on this road on which the biker is moving, the speed limit is 60 kilometers per hour. Unknown to him, a policeman follows the biker on a vehicle with an acceleration of 2 meters per second square, starting from rest. After what time will the policeman catch up with the biker? What would be the speed of the policeman at that time? Remember, the speed of the biker is constant at 72 kilometers per hour. The solution of this problem: the given speed of the biker is 72 kilometers per hour, which is 20 meters per second. Suppose the policeman catches up with the biker after time t. You see, if something is unknown, you assume, as in this case we assume time to be t. In that time, the biker travels a distance of, with a constant speed of 20 meters per second, a distance of 20 meters per second into t seconds, which means 20 times t meters. In that time, the policeman travels the distance is half into 2 meters per second square into t square, that is s equal to half a t square. Equating these two distances, we get t equal to 20 seconds. So, we know that in 20 seconds the policeman is able to get to the biker. The speed of the policeman at that time is given by v equal to a t, because u is 0. So, v is equal to a t, that is 2.0 meter per second square into 20 seconds, which is 40 meters per second. Let us take another example. A train is moving at a speed of 10 meters per second when the driver applies brakes which provide deceleration of 1 by 20 meter per second square for a distance of 750 meters. What time does the train take to travel this distance? What is the speed of the train at that time? In this case, we are given deceleration. Deceleration is the negative of acceleration. If the speed increases, it is called acceleration. If the speed decreases, it is called deceleration or negative acceleration. So, what is the solution? Using s equal to u t plus half a t square, in this case u t minus half a t square, because acceleration is negative, we get a quadratic equation in t, that is t square minus 400 t plus 30,000 equal to 0. Now, this is a quadratic equation and it has two roots, and the two roots are t equal to 100 seconds and t equal to 300 seconds. Once again, we get two values and we have to choose one value using other considerations that we can have. Whenever there is this kind of situation, we have to apply our judgment to choose the correct value. So, what do we do? In this case, we take v equal to u minus a t, substitute the value of a, u and t equal to 100 seconds and t equal to 300 seconds. We get both the values, and in one case we get v equal to 5 meters per second, in the other we get minus 5 meters per second. Since 5 meter per second seems to be the correct value, because the train is slowing down, it is not going in the opposite direction. Therefore, we choose t equal to 100 seconds. So, once we have chosen t equal to 100 seconds, then we can work out the other relations if required. In this lecture, we have seen how we can use kinematic equations to solve problems. I will draw your attention to three important points. 1. Write down all the quantities that are there and then those which are given, and then find the appropriate equation which covers the given quantities and the quantities which we have to find. 1. The second, you may get a situation where you get two values, because equation s equal to half a t square can give us two values of t. It is a quadratic equation. So, therefore, we have to choose one value which is more suitable. Similarly, v square minus u square equal to 2 a s can give you two values of velocity, because again it is quadratic in v square or u square. Therefore, again we have to choose, we have to use extra information that we might have to choose the correct value. So, this is how we use the kinematic equations to solve problems which are based on these equations. In the next lecture, we shall consider again kinematic equations, but with velocity in the vertical direction.